Hey, it's Mr. Shrum, and I am back with a physical science tutorial walkthrough. And we're going to start with some information about energy and the forms of energy for Unit 2. So let's get into the basics. What is energy? You hear that term all the time, but what is it in the realm of physical science? The universe is made up of two fundamental quantities, matter and energy. We can see matter, but not energy itself. However, we can see the effect of energy on matter. Energy makes matter move and changes it. There are different forms of energy, such as thermal energy, radiant energy, and electrical energy. We cannot create energy or destroy it. We can only change its form from one to another. And this idea is known as the law of conservation of energy. Another aspect of energy is that it can be transformed from one object or place to another. So, for example, the energy in a piece of fruit is transferred to the person eating it. There are chemical potential energy in fruit in the forms of sugar, carbs, starches, and that is digested by the person and transformed into another form of energy. So there is a lesson activity here about watching a video and then answering the following questions. I'll let you watch that video on your own. And then we can move on to forms of energy. So energy is present in many forms. It can also change from one form to another. All forms of energy belong to one of two categories. You have kinetic energy or potential energy. And kinetic energy is the energy of motion, movement in a body. While potential energy is stored energy, potential. It's energy that can be used, but is not necessarily being used at this moment. So objects that move from one position to another have a kind of kinetic energy that is sometimes called motion energy. The main difference between kinetic energy and potential energy is that an object can transfer kinetic energy, but it can only store potential energy. For example, a moving cue ball, this white ball here, will transfer its kinetic motion energy to the eighth ball, this black ball here, when the balls collide. And now we can click on these pictures to look at the different forms of kinetic energy. The first one is motion energy. That's associated with an object that moves from one position to another. A moving car is an example of something with motion energy. Thermal energy is the energy of the motion of particles at the atomic level. Heat usually increases thermal energy. A change in the amount of thermal energy causes a corresponding change in temperature. Thermal temperature. Then you have electric energy, and this is associated with electric currents. Electric energy is generated by moving electric charges. And because these charges are moving, electric energy is a form of kinetic energy. All active circuits have electric energy. So think of running electricity as movement, actually. And then you have vibrational energy. That is energy that travels in the form of vibrations through air or other materials. Water waves and sound waves are examples of vibrational energy. We use musical instruments to create vibrations that result in sound. Then lastly, we have radiant energy. Radiant energy is energy that is transferred by electromagnetic waves. Radiant energy can travel through space and reach any place in the universe. Light, ultraviolet rays, radiant heat, microwaves, X-rays, and radio waves are examples of radiant energy. On the other hand, we have potential energy, and that is energy stored within an object. An object can have stored energy because of its position. So in the example at the beginning of the lesson, there was a warm-up question about a bicycle rider, and a bicycle have potential energy when they're at the top of the hill. So being on top of the hill and moving down the hill, that bike and cyclist at the top of the hill have the potential energy to move down that hill because of how high they are. So gravitational potential energy is related to gravitational force. Other kinds of potential energy are related to other forces. And let's explore some of those forms of potential energy. And in this picture here, we have the man on top of the ship, this is a ship, has more gravitational potential energy than the man he's helping because he's higher up because of his position. And now we can look at the forms of potential energy. We talked about gravitational potential energy. That is the energy an object has because of its position in Earth's gravitational force field. Water stored in an elevated tank is an example of gravitational potential energy. Then we have elastic potential energy. Elastic potential energy is stored by an object when its shape is changed by stretching or compressing it. Examples are rubber bands, bungee cords, and springs. This form of stored energy arises from the position of molecules within the material. Then there is chemical potential energy. And there are two types of chemical potential energy. One is stored by the relative positions of atoms within molecules. Food and fuels have this kind of chemical potential energy. Another kind of chemical potential energy is energy stored when matter changes state between solid, liquid, and gas. Then there's electric potential energy. When charges exert forces on each other, they can have potential energy because of their position. And this form of energy is called electric potential energy. Storm clouds and batteries have electric potential energy. Magnetic potential energy depends on a magnetic material's position with respect to a magnetic force field. The energy stored by metal filings or magnets present in a magnetic field has a magnetic potential energy. And lastly, we're going to talk about nuclear potential energy, and that is associated with subatomic particles. So tiny, tiny particles. And this type of potential energy is stored by the positions of subatomic particles inside an atom. Energy is involved in all our daily activities. We have different forms of energy, and we know they are present because of the effects they have on us and our environment around us. All moving objects have motion energy. All objects, whether moving or not, have thermal energy because of the motion of their particles of matter. They also have different kinds of potential energy. Here on Earth, radiant energy from the sun, often called solar energy, is the main source of all forms of energy around us. Solar energy causes weather by moving air and water. Plants use solar energy to make food and fuels. Food moves us, and fuels move our machines and generate the electricity we use. The sun is a natural source of both thermal heat energy and radiant light energy. So we're asked a question. Which statements about energy are true? Well, we said that energy is conserved, so it's never destroyed or created. And it has the ability to move matter. Cool. Next question. So identify which form of energy is represented by each image. So we have a moving car. Moving kinetic motion is called motion energy. Then we have a guitarist playing a guitar and vibrating strings. That is vibrational energy. And then we have someone pulling back a rubber band and about to shoot it. And that is elastic potential energy. Now we're going to move on to energy transformations. So how does energy transform from one to another form of energy? Now, this ability to change is one of the most important aspects of energy. And these transformations occur when matter and energy interact with one another. So, for example, when a child goes down a water slide, the child's gravitational potential energy transforms into motion energy. A toaster transforms electric energy into radiant energy or thermal energy. And a television transforms electric energy into radiant energy and sound. So in every energy transformation, there is a small amount of energy that is given off as heat. And heat is a form of energy that can't be transformed into the desired energy form. And this happens because of friction and drag. So in most cases, the heat increases thermal energy. When the child moves down the slide, both the child and the slide gain a small amount of thermal energy. Feel this effect by rubbing your hands together. Both of your hands will get warm, and that is the heat being given off. And then we have activities after the slide about describing energy transformations. I'll let you do that on your own. And then we continue with looking at the transformation of energy. We can describe energy transformations with energy chain diagrams. So look at this type of diagram. You have a battery, and that is your source of power. When the phone is turned on, the battery's potential electric energy transforms into electric energy as current. The electric energy transforms into sound energy, light energy, and thermal energy. So when you hold your phone, it is warm at times. The chain diagram is actually part of a larger one. You can always extend the chain diagrams forward and backward. For example, there's chemical potential energy in the substances within the battery, even before the electric potential energy that's shown. So what gives this electrical potential energy is the interaction of chemicals within the tiny battery. And this chemical potential energy is transformed into that electric potential energy when the substances are separated at the battery terminals. Deciding where to start and end these types of chain diagrams is always a challenge, right? You have to decide what you want to show. That asks you to draw a energy transformation, but we're going to skip though. Oh, excuse me. I'm going to skip that. I'm going to skip that again. And then we'll go over that in the mastery test walkthrough. But I would just like to get through these slides first. Then we're going to talk about science in the news, and this will focus on nuclear energy. Now, this is a form of energy that has many applications. A nuclear reaction is an interaction of matter in which atoms change. There are two types of nuclear interactions or reactions. We have nuclear fusion, in which molecules fuse together, and then we actually have nuclear fission, where things are actually broken apart. When two atoms fuse to produce a larger atom, that is nuclear fusion. When an atom is split into two or more smaller atoms, nuclear fission has occurred. And if this is carried out on a large scale, there can be a lot of energy created, not created, but transformed, because energy is not created or transformed or destroyed. It's not created or destroyed. It is only transformed. Nuclear fission is used in nuclear power plants to generate electricity. The plant controls the rate of the nuclear reaction. The reaction is started by splitting a few atoms. While splitting, these atoms emit energetic neutrons that split other atoms. The result is that many atoms are split and a huge amount of energy is released. That is called a chain reaction, as in one little split of an atom leads to many other atoms splitting. However, nuclear fission uses and produces radioactive elements. Radioactive elements emit high energy atomic and subatomic particles and radiation. These radioactive emissions are harmful and must be contained to protect people. For this and other reasons, nuclear energy is a heavily debated topic. Yeah, if you would like to do more research about nuclear energy, I encourage you to. Several nuclear power plant accidents have leaked harmful materials. The 1986 Chernobyl accident in Russia occurred because of faulty reactor design. A fire followed by an explosion released radioactive particles into the air. Within a week, 28 people died from acute exposure to radiation. A United Nations committee studied data after the accident to find out how people in the wider area were affected. Sadly, they found an increase in thyroid cancer cases. A major earthquake on March 11, 2011, caused a 15-meter high tsunami to hit the Fukushima nuclear power plant in Japan. This force disabled the system used to control the nuclear reaction rate. The result was a series of explosions that released radioactive gases into the air and water. The government took immediate measures to evacuate thousands of workers. The evacuation saved them from the harmful effects of radiation. Here we have a person holding a dosimeter, and that measures the radiation levels of an area. And they are in the Chernobyl nuclear power plant. That is in the background. I would encourage you guys to look up on YouTube about abandoned nuclear power plants or radioactive parts of the Earth, because I wouldn't want to personally go there in person, but it's fun to look at online, to look at how even after all these years, the radioactive material is still present. Yeah, but that was nuclear fission, as in atoms are being split apart. On the other hand, we have nuclear fusion. Fusion is when two or more atoms collide at really high speeds and then they fuse together. So that is the fusion part of nuclear fusion. Atoms collide and then they fuse into a larger atom. Fusion reactions are the source of energy inside stars. Nuclear fusion inside the sun produces all of its radiant energy. Some of this energy reaches Earth even though we're 93 million miles from the sun. 93 million miles. And we can still see it. Like fission, nuclear fusion reactions produce a huge amount of energy. Unlike fission, fusion doesn't use or produce radioactive elements, nor does it pollute the environment. Scientists are researching how to carry out nuclear fusion reactions to provide a clean, non-polluting source of energy. We have another lesson activity and then the summary. So that is it for forms of energy. If you have any more questions, message me in Canvas and I will help you out. And I will also walk through the mastery tests material in another video. But until then, have a nice day / weekend, and I will see you all next time. Bye-bye.